we live on a planet that seems familiar. Humanity has reached the moon, explored Mars, and observed galaxies billions of light years away. Yet directly beneath our feet lies a world no human has ever seen. A place where temperatures reach thousands of degrees. Solid rock moves slowly over millions of years, and liquid metal helps create the magnetic field protecting life. So what is actually inside the Earth? From space, our planet looks calm and peaceful. But beneath its surface is a powerful heat engine that has been active since Earth formed about 4.5 billion years ago. Some of that heat remains from the planet's formation. More is produced by radioactive elements deep underground. This energy drives volcanoes, earthquakes, moving continents, and many of the processes shaping the surface. But humanity has barely entered this hidden world. The deepest hole ever drilled reached only a little over 12 kilometers. Earth's radius is more than 6,300 kilometers. If the planet were the size of an apple, our deepest drilling would be little more than a scratch on its skin. So scientists do not study Earth's interior by simply digging downward. They study earthquakes. When an earthquake occurs, seismic waves travel through the planet. Some waves can pass through both solid and liquid material. Others move only through solids. By measuring their speed, direction, and the places they cannot reach, scientists can build an indirect picture of the world below. This reveals four main layers: the crust, the mantle, the outer core, and the inner core. The crust is where all human history has taken place. Cities, forests, mountains, and oceans sit on this thin outer shell. Oceanic crust may be only several kilometers thick. Continental crust is thicker, especially beneath major mountain ranges, but compared with the entire planet, even the thickest crust is extremely thin. It is also broken into enormous tectonic plates. These plates move only a few centimeters each year. That sounds insignificant. But over millions of years, this motion can open oceans, move continents, and raise mountain ranges. The Himalayas are still rising as the Indian plate pushes into the Eurasian plate. The Atlantic Ocean is also slowly widening as new material rises along the mid-Atlantic ridge. The world map we know today is only temporary. Beneath the crust lies the mantle, which makes up most of Earth's volume. It is often shown as an ocean of lava, but that image is misleading. Most of the mantle is solid rock. Under immense heat and pressure, however, that rock can slowly deform and flow. Hotter material rises from below. As it cools, it sinks again. This extremely slow circulation helps move the tectonic plates above. At plate boundaries, stress can build for decades or centuries. Eventually, the rock breaks. Stored energy is released within seconds, and the ground begins to shake. That is how many earthquakes begin. Volcanoes are another result of activity beneath the crust. In some regions, rock melts, and forms magma. Because magma is often less dense than the surrounding rock, it rises through cracks. When pressure becomes too great, lava, ash, and gas may be forced onto the surface. Volcanoes can destroy cities and reshape landscapes, but they also create. They built islands, carry minerals upward, and helped release gases that shaped Earth's early atmosphere. Some of the most fertile soils on the planet were formed from ancient volcanic material. At a depth of about 2,900 kilometers, the mantle ends and the outer core begins. This region is made mainly of molten iron and nickel. Its temperature reaches several thousand degrees Celsius. The liquid metal does not remain still. It constantly moves and circulates. Combined with Earth's rotation, that motion produces electrical currents. Those currents generate the planet's magnetic field. This invisible shield helps redirect many charged particles coming from the sun. Without it, Earth's atmosphere and modern technology would be far more exposed to space weather. Even the auroras near the poles are connected to this hidden process. The beautiful lights above Earth are partly possible because molten metal is moving thousands of kilometers below the surface. At the center of the planet lies the inner core. It is a solid metallic sphere, more than 1,000 kilometers in radius. Its temperature may be similar to the surface of the sun, yet it remains solid. The reason is pressure. The weight of the planet above presses inward so strongly that the metal atoms are forced into a solid structure. The inner core is also slowly growing. As Earth cools, some liquid metal from the outer core freezes onto it. This process releases energy that helps keep the outer core moving. That movement allows Earth's magnetic field to continue. No human or machine has ever reached the mantle, outer core or inner core. Every cutaway image of Earth is a scientific model built from seismic waves, laboratory experiments, magnetic measurements, and physics. We have never directly seen the core. We know it exists because of the way the planet vibrates, and many questions remain unanswered. Scientists are still studying how the mantle moves, what strange structures may exist near the core, and how the inner core changes over time. Every major earthquake sends new information through the planet and adds another piece to the picture. Earth's interior is not an empty space. It is also not one giant ocean of lava. It is a layered system driven by heat, pressure, moving rock, and flowing metal. These hidden processes create continents, raise mountains, power volcanoes, and produce the magnetic field protecting life. The ground beneath us feels solid and permanent. In reality, it is only the outer skin of a planet that is still changing. Continents continue to move, the core continues to cool, liquid metal continues to flow, and the great engine inside Earth has been running for billions of years. We often search for strange worlds far beyond our planet, but deep beneath our feet, Earth already becomes a completely different world. A place no human has entered, hotter than any desert, under pressures beyond anything on the surface, and so important that without the processes happening below, the world above would not exist as we know it.